In this video, we're going to be looking at full wrap engraves, as well as wrapping tapered surfaces and how to compensate for those tapered surfaces. I'm going to be using the XTOOL F1 to demonstrate, but the concepts in this video can be applied to any other machine. I've got lots of examples, so I'm going to be going as in-depth as possible. And as always, any tools or things that I reference in this video can be found in the links in the video description down below, including links to the XTOOL F1 itself. This has been one of my favorite machines to use for its compact size as well as its dual blue and IR lasers. I made an entire video about Tumbler engraving with the XTOOL F1. So if you guys haven't watched that video yet, I would highly encourage you guys to go check that out for a foundational understanding of how the rotary system works with the XTOOL F1. And just before we start, I want to mention that XTOOL recently announced the release of the F1 Ultra, which is going to be a dual blue and fiber laser, and that fiber laser will be a first for XTOOL, and it's going to come in a similar compact form factor as the regular F1. I'm going to have videos on that machine coming up, so be sure to subscribe so you don't miss those, and check the link in the video description down below for a special pre-order offer. So let's not waste any more time and let's get started. For our first example, we'll start with the most basic of shapes, and that's going to be a regular cylinder. And we need to know a few things. So I'm going to be using my digital calipers here to first measure the outside diameter of the cylinder, which is about 80 millimeters. The next piece of information that we'll need is the height or width, depending on how you look at it, of the surface. And in this case, it's also 80 millimeters. Now for some of you, this might be obvious, but what we're going to do here with this information is take the surface of this cylinder and unravel it into a rectangle. We already know that the height of the rectangle is 80 millimeters, and by simply multiplying the diameter, 80 millimeters also, by 3.14, we get the length of that rectangle. We'll remember those numbers, and now I'll be setting up my cylindrical workpiece in my rotary module. And if you guys happen to be working with an XTOOL RA2 rotary module, you can see that I've upgraded mine here with my tilt mechanism, which will allow me to tilt my workpiece if it's tapered, but in this case, it's just a plain cylinder, so it won't be tilted and it'll just sit completely straight for this straight cylinder. Then I can position my workpiece inside of the working area of the XTOOL F1 and then set the focus to the top of this cylinder. My tilt kit also makes this very easy to do on the XTOOL F1 because it aligns the center axis of rotation with the center of the work area. And if you guys haven't been able to tell, these sample workpieces are 3D printed, and there's this vertical line that runs up the cup, and this is known as a seam in 3D printing. And this will conveniently serve as a nice visual reference for a start and stop point. Now I'm going to be using Adobe Illustrator for this example, but regardless of what you're using, what we need here is a canvas size with an 80 millimeter width and a 251.2 millimeter height. And if you recall, these are the dimensions that we measured and calculated for the surface of our cylinder unraveled. And to demonstrate the premise of a full wrap engrave, I've just created a simple grid pattern here. You'll notice that the grid rectangles at the top and bottom are half the size of the other rectangles, so when this pattern is engraved full circle, those two rectangles should connect if we do everything right and make a full-size rectangle. Now I'm in XTOOL Creative Space and I've set my laser mode to cylindrical. I've noted that we're using the chuck, and I've set the diameter to 80 millimeters, and I've imported my grid graphic. If you're using a different brand of machine, or if you're using Lightburn with an XTOOL product, things will obviously look different for you, but again, the premise here should be the same. I have my grid graphic moved right up to the y=0 line, up at that green line at the top of the workspace. And right now, all I'm doing is changing my raster image and tracing it into a vector image and setting all of the properties to engrave. And on these 3D printed parts, I'll be using the IR laser of the XTOOL F1 to get a nice marking on the plastic. The next step is to frame our graphic on the workpiece, and the XTOOL F1 makes this very easy as it projects a blue laser line down the center of the object. And the goal here is to get the two ends of this line touching the top and bottom of this cup. If you recall, our cup is 80 millimeters tall, and our graphic is also 80 millimeters tall, so it should reach both ends. Then I can just start this job, and a short while later, you'll see the results. And the nice thing here, as I mentioned earlier, is that this seam on the 3D printed part is a very nice visual reference for us to see where this graphic started and stopped. And you can see with our calculations, we were dead on with the size of the surface as it was unraveled because the start and stop point connect. If that seam feature wasn't present on this part, you may not even visually be able to tell where the graphic starts and stops, and this is perfect. Now that we understand the basic premise and workflow, we'll do a more interesting example, and we'll be using the same size cylinder for this. And so I'm using the same size artboard here. I've just rotated it 90 degrees so it fits better on the screen to show you guys. And I've got a vector graphic here of a pineapple. We'll set up a fun pineapple pattern across the surface of our workpiece. And so I'm just going to copy and paste this vector object a few times onto the artboard. And on the left-hand side, you'll see that I've rotated those pineapples a little to the right, and the other pineapples are rotated a little to the left, and they're sort of placed between the 3 pineapples on the left-hand side. Now, I'm not an expert graphic designer, but I believe this will be what is known as a half drop pattern. And so I've grouped those pineapples together, and in Adobe Illustrator, we're going to be using the repeat grid feature here. The grid tool allows me to take my group of pineapples and stretch the pattern, crop the pattern, and then also using the slider in the middle, I can adjust the spacing between my pattern as well. And if you look closely, one thing you may also notice is that the pineapple pattern is not perfectly repeating. There is some variation where it alternates between upside down and upright pineapples. This is an optional feature that can be turned on or off inside of the repeat grid tool. And so if you just go into repeat and then options, you'll see there that there are some options under grid where you can flip the columns, flip the rows, and change the grid type. I'm going to be leaving the flip column option turned on because I think it just makes the pattern a little more interesting. And full disclosure, I am not a graphics design expert by any means, so there's probably a better and more efficient way to do this, but at least for me, I find this to be the easiest way to get the pattern that I'm looking for. And if you're not using Adobe Illustrator, there are probably similar tools in other software. Now what I've done is I've taken my pattern, and you can see the pineapples on the left-hand side. I've moved to the edge of the artboard so that half of them are cut off. And now I'm going to use the grid tool to manipulate the pattern so that the same 3 upside down pineapples will be positioned roughly in the same place on the right-hand side of the artboard, also cut off roughly in the same spot. Don't spend too much time driving yourself crazy trying to get them exactly in the same position. If it's a tiny bit off, in the end, you won't really notice anyways. Once we're happy with the spacing and positioning, now we need to get rid of some pineapples. So I'm going to go into Object, Expand, and this is going to give us all of our individual pineapples back. And you can see that the grid tool has grouped the individual columns of pineapples. So I can go ahead and select the column of pineapples on the far right hand side and just delete those. Now I can use Control A to select everything and use the arrows on my keyboard to incrementally push the pattern back over to the right hand side and more or less try and center it on our artboard. On this half drop pattern, you'll see that there are 3 pineapples on the left hand side and 2 on the right hand side, and this is what we want for the appearance of a repeating pattern once the engraving is done full circle 360 degrees on our workpiece. Now you can export this as an SVG vector, or if you prefer to work with PNGs, you can export it as a PNG, in which case you'll probably want a transparent background. I'm going to elect to bring the SVG vector file into XTOOL Creative Space, and I want to display it in its original size as we don't want to mess with the scaling. I'm going to take this and rotate it 90 degrees, and then I'll align it on the center of the workspace. I'm going to be manually positioning this graphic vertically, but in retrospect, there's a much better way to do this, and that would just be to draw a rectangle around the whole graphic the size of the artboard while I was in Illustrator, and that would get imported in here, and I could align that rectangle with the green line, which is y equals 0. I'll show you guys that in a future example in this same video, but for now, I'm just eyeballing it, and I'm going to be drawing that same rectangle in XTOOL Creative Space instead. So you'll see me draw that rectangle here, and I'll change the height to 251.2 or 3, which is the size of our unraveled surface of our cylinder, and I'll change the width to 80 millimeters. Now, this rectangle, I'll move it to a new layer so it's easier to see, and I'll just set it to engrave so we have a nice solid red background, and I'll center that in the middle, and I'll move that to the y=0 position. Then I'll make the group of pineapples visible again on top of the red rectangle, and this is where I'll try and adjust that spacing manually so the pineapples are positioned in the middle of the rectangle. And so again, this is not the most ideal way of doing it. I'll show you that better way very soon, but it should work for us. The other purpose and advantage of having this rectangle inside of our workspace, whether we've created it in XTOOL Creative Space or in Illustrator, is when we go to frame this graphic on our workpiece, it's going to make the placement of our graphic in the framing process so much easier because the height will be 80 millimeters and the projected blue line from the XTOOL F1 will just reach from edge to edge, and we know our pineapples will be centered on that rectangle. Just always remember before you start processing the job that no matter what software you're using, you either want to delete that rectangle before starting the job or disabling the output. You obviously don't want to engrave a solid rectangle. And in this case, you can see I've got all of the pineapples. And again, you can see the seam on the 3D printed cup shows us our start and stop position, and the pattern looks seamless. The spacing between all of the pineapples is very uniform. And again, once you get back to that 3D printed seam, if it wasn't there as a visual reference, you wouldn't even notice where the start and stop position is. Now this next example is another cylinder that's 80 millimeters in diameter, but it's twice the height at 160 millimeters. If you're using a bigger gantry style laser, this example will be very easy for you. But if you're using the XTOOL F1, then a good portion of your workpiece will not fit within the working area, and you're gonna have to process this job in two parts, and I'll show you guys how I approach this. Now, if you're sick of pineapples, we'll switch things up a little here, and we're going to be using strawberries instead. And we're going to do a similar pattern where I've got 3 strawberries on the left-hand side tilted one way, 2 strawberries to the right of that, and those again are placed in the middle in this half drop pattern. If you guys have been paying close attention, you might be wondering why my artboard still only looks 80 millimeters tall. And that's again because on the F1, we're going to be processing this job in 2 parts. Now, if you had the larger gantry style lasers, I would definitely recommend doing it all in one shot and changing your artboard height to 160 millimeters. And then you would pattern your strawberries all the way down to the bottom of the 160 millimeter height and process everything in one shot. But if you're using a small format laser, you can see that I'm still following the same procedure as the 80 millimeter height cup. And so I've got my strawberries and I'm stretching out this pattern so that the same upside down strawberries on the left side match the right side. They're both half cut off. Then I can expand the graphic, delete the rightmost column of those strawberries, center the whole pattern, and then make sure again that on the left hand side, I've got the 3 upside down strawberries. On the right hand side, I've got 2 strawberries as part of that half drop pattern. And now what I can do is resize my artboard. And this is when I'm going to change the height to 160 millimeters. And you can see I've checked off the little box there that allows my current graphic to stay centered at the top of the artboard as it was resized. Then I can take the entire pattern, copy it, paste it, and I'm just going to reflect the pattern so that the spacing of the strawberries looks continuous. Just remember that by no means do you have to do it this way. There's always more than one way to accomplish the same thing. This is just one of the easiest methods that I use to quickly create an interesting looking pattern. In the last example, I mentioned that it's much easier to draw our background rectangles inside of Illustrator, or if you're using Inkspace, I'd imagine it's the same thing. And so I'm going to take a rectangle, I'm going to size it to the width of my artboard, and then I'm going to make the height 80 millimeters. So it's exactly half. I'll position it at the top of the artboard, copy it, paste it, and now I have a second rectangle on the bottom of the same size, and I'll just change the colors so you can see that they're visually different. And as I'm importing this graphic into XTOOL Creative Space, one other important thing to take note of here is that you'll notice that the division of my pattern of strawberries does not overlap the center line between those two different color rectangles. I've spaced out the pattern of strawberries with this specifically in mind for the XTOOL F1 because again, we're going to be processing this in 2 jobs. If you have a larger laser, this is not something you need to concern yourself with. So now what I've done is I've taken the pattern of strawberries in front of the peach colored rectangle and I've centered those in my workspace. And I'm going to take that entire pattern of strawberries and the rectangle, I'm going to group them together. I'm going to hide the green half and I'm also going to disable its output because those ones will be a part of the second job. And so with those ones gone, now we can focus our attention on this visible half of the pattern, and I'm just going to make sure that again it's aligned inside of the workspace at the center, and then I'll move it up to the Y equals 0 position on that green origin reference line in XTOOL Creative Space. Now sometimes you'll see me manually drag these things around. However, the easiest way to do it is just to click on the group in the layer section, and on the right hand side just type in 0 under the Y position. Now we can frame this job and you can see that I've got the right side of the laser projection representing the height of our graphic aligned with the right side of the cylinder, which is the top of our cylinder. And before starting this job, the last thing I need to do is just find that rectangle in my object list, and I'm going to make sure that I've disabled the output and I can hide it, and then we can process this job. I know I'm going to sound like a broken record for those of you guys who actually watch these videos from start to finish, but I know a lot of you skip around. And so I just want to repeat myself again that this method here of doing half the workpiece at a time is specifically for smaller lasers like the F1, where you wouldn't be able to fit the entire pattern in one shot. Now here you can see that half the pattern is engraved, and it's very important that I do not rotate the workpiece. I'm just sliding it down so that now we can take our second pattern, make that visible, and turn the output on in XTOOL Creative Space. I can hide and disable the pattern that we just did. And now I can take our second pattern, position it into the middle of our workspace, also move it to the Y equals 0 position. And now I can frame this pattern and I can use the left side of the laser projection and line it up with the bottom of my workpiece. And because I've made the 2 halves of the graphic equal height, 80 millimeters, and those 80 millimeter rectangles are part of this framing process, this should ensure that everything is lined up perfectly. Now when I go to process this job, the original pattern spacing is maintained and the alignment between those 2 halves should be very accurate. Now obviously this is just an example, and you can spend a lot more time designing your patterns, and you can even make them continuous where, like the grid pattern, they'll wrap around and touch each other. And if you're very, very careful, even on the F1, you can get the alignment perfect so that those continuous patterns would be seamless. However, what's nice about working with discrete graphics like these individual strawberries is that it's visually more forgiving. If you have to split jobs up into 2 parts like this, small differences in spacing won't be visually noticeable. Whereas if you had connecting lines that were disjointed due to a mistake in your setup, it would be really noticeable and it would look bad. Up to this point, we've been working with cylinders, and although a lot of water bottles and tumblers are cylindrical, some are not. Some are tapered, and so I've created these tapered test pieces here with a small cylindrical section on the top that just makes it easier for us to grip with the RA2, but we're going to be putting the grid pattern onto the tapered surface to see what happens. My test workpieces have a large diameter of 80 millimeters and an overall height of the tapered section also of 80 millimeters, and the smaller diameter is about 54 millimeters. And so I'm using the exact same grid pattern design that I used for the regular cylinder. And for this first example, I have not tilted the tapered cup. I briefly ran this job and noticed that I didn't have it positioned correctly, so just ignore those 3 little lines there. After restarting the job in the correct position, the takeaway from this example is that you'll notice the grid lines fading, and that's from the laser falling out of focus because I did not use the tilt mechanism. And the other thing you'll notice is that those vertical lines will start to converge. Now we can very easily fix the fading lines by using the tilt mechanism to tilt the tapered cup upwards so that the tapered surface is now parallel with the laser and it will not fall out of focus across that entire surface. Then I can just refocus the laser on that surface and start the job again. Just a reminder, if you guys have an XTOOL F1, I've got the tilt mechanism available on my website, embracemaking.com, and I've got a kit for the XTOOL D1 Pro that should also fit various other XTOOL models. With this job complete, you can see that the grid pattern is still continuous even on a tapered surface, and the grid lines will connect on the 3D printed seam. And so full wrap patterns are definitely possible on tapered surfaces. However, we still have to deal with these converging lines. And on this grid pattern, it's not such a big deal. But now if you're dealing with something where you have graphics like these pineapples, what you'll notice is that the pineapples at the smaller end of the taper will be smaller and look more squished than the pineapples at the top. And that's because the surface is tapered and the diameter is decreasing as you move your way down the cone, and the software is not accounting for that. In the software, you just enter in the major diameter, which is 80 millimeters, and the incremental angular rotation of your rotary module is linked to that 80 millimeter diameter. It stays consistent. In our design software, we need to try and find a way to take our unraveled cylindrical surface, which is a simple rectangle, and somehow map it onto the unraveled tapered surface, which is not a rectangle. Ideally, what we would like to accomplish is to be able to take one of those rectangles from the grid pattern, and if we were to engrave it onto this tapered surface, it would still look like a rectangle where the vertical lines are parallel and no longer converging. And this is possible to do. Some of you may already know that you can distort your graphic to compensate for this, but I wasn't happy with just eyeballing it, so I did a bunch of math to take the guesswork out of this process, and I came up with something that works. All you'll need to do is take some very basic measurements of your workpiece, and the first measurement is the large diameter of your cup or workpiece. In this case, it's 80 millimeters. And then you'll need the second measurement, which is the smaller diameter, and in this case, it's 54 millimeters. And then I just need the distance between those two diameters. And so on these cups, as I had previously mentioned, it's also 80 millimeters, and there's various different ways that you can go ahead and measure that distance. So you want to get as close as possible with your measurements, but as long as you're in the ballpark, it'll still look pretty good. Now, to save you guys from doing the math part, I've created a calculator on my website. I'll put a link in the video description down below to where you can find it. It has diagrams and graphics showing you exactly what you'll need for inputs. So just as we've already measured the large diameter, the small diameter, the distance between those two diameters, and the only other three pieces of information that you'll need is the distance from the top of the large diameter to the start of your logo, and then the nominal dimensions in the X and Y of your logo. All of this is described and outlined on the webpage, so you can also go through this at your own pace just by reading the description. The output from the calculator will give you X1 and X2, which are the dimensions of your distorted graphic. The height of your graphic will not change. I'll take you guys through a few examples. It's definitely not as difficult as it may first appear. And so I'm entering in all the information: my major diameter, 80 millimeters, my minor diameter, 54 millimeters, the height between those two, 80 millimeters. I'm going to be aligning my graphic right at the top edge of the large diameter, so Y1 is 0, and then the nominal dimension of my square is going to be 20 millimeters by 20 millimeters, and when I click on calculate, it'll give me the X1 and X2 dimensions, which we can write down and remember. For this simple example, we'll just be engraving a solid square, and in future examples, I'll show you guys how to use this method with patterns and logos, but for now, we'll draw our square, and I'm going to change the dimensions of the square to 20 millimeters by 20 millimeters. The X1 output from the calculator was still 20 millimeters, even though the nominal dimension was also 20 millimeters. And that's because I set the Y1 dimension, which is the distance from the top of our logo or square to the large diameter. I set that to 0. So this is totally normal that the nominal dimension and the X1 is the same here. In Adobe Illustrator, I'm going to be using the freeform perspective distort, and I'm going to drag out one of the bottom corners, and I'm going to set the length of that line to the X2 output from our calculator. The calculator output was 21.77, and I got it to about 21.75, so that's close enough. And then I'll just fill the square in so it's solid black. And now if I fit the artboard to this graphic, you can see that there are those slivers of white peeking out from behind the black trapezoid. So you can definitely see that the left and right side edges are angled in the same amount. I can now save this file and bring it into XTOOL Creative Space, and I'm going to select the graphic and I'm going to rotate it 90 degrees. For my workpiece, I want the smaller edge, which was the X1 dimension on the right hand side, and this is going to line up with the larger diameter. And I want the longer edge, which was the X2 dimension, to line up with the smaller diameter on my workpiece. And as you guys can imagine, this is going to compensate for that taper. I've also copied and pasted this graphic and placed the copy further down the workpiece so we can see what's going to happen to it dimensionally when it's not placed in the correct location as we entered in the calculator. So again, the Y1 location was 0. And so the trapezoid on the right hand side will line up with the top edge, the big diameter of our tapered surface. And the trapezoid on the left, which is the exact same size, has been misplaced further down the tapered workpiece. You'll also notice that I quickly traced those images to turn them into vectors in XTOOL Creative Space, but that's more or less irrelevant to this process. So you can see I'm pointing to where the large diameter of the tapered surface starts. And when framing this job, I want the right edge of the framing projection to line up with the larger side of the taper here. One other very important detail here is that we use the larger diameter, so in this case 80 millimeters, in the workpiece dimensions in XTOOL Creative Space or whatever software that you're using. This is very important because the calculations are based on the assumption that your software assumes you're using a cylinder with that larger diameter. And as this job runs, you can see I've got a few other test squares at the bottom of this workpiece, so we'll just ignore those. The ones that just finished processing, we can now have a look at. And right away you'll notice that the one on the right hand side, which was appropriately lined up with the larger diameter, looks like a square. And we can verify with our calipers, so it should be 20 millimeters wide by 20 millimeters tall if the calculation was done correctly, and this does look good. Now just a reminder that the graphic on the bottom was copied and pasted a little bit lower, and you can see that it's still 20 millimeters tall but only 17 millimeters wide, and that's because in our calculator I had the Y1 dimension set to 0, which is the distance from the top edge of the graphic to the larger diameter, and so I purposely moved this copy of the graphic down farther from the larger diameter so you could see the effect. The left and right edges will be parallel, the height will also be correct, but the width will not. Now we can go back and revisit our pineapples and apply these same concepts to fix this graphic. Back in Adobe Illustrator, I'm going to start with just 3 pineapples so the effect is easier to see. And the first thing I'm going to do is just draw a rectangle. I'm going to take this rectangle and I'm going to fit it around the 3 pineapples. And so I want the height of the rectangle, in this case, to be 75 millimeters, which should stretch from the very top of the top pineapple to the very bottom of the bottom pineapple. And then I'll change the width to 13 millimeters. And this is from the left edge of the pineapple to the right edge of the pineapples. And then I'm going to center it around those graphics. And so the concept of what I'm doing here is just drawing a bounding box around the graphic. If you're not working with pineapples, it doesn't matter what it is, you're just drawing a box around the graphic so it touches the top, bottom, left, and right edges of that graphic. With our bounding box dimensions, we can hop back into the calculator. Now in the calculator, we're going to be using those dimensions from the cup. So I already know that the major diameter is 80 millimeters, the minor diameter is 54 millimeters, the height is 80 millimeters, and we're placing this graphic 3 millimeters from the major diameter. My nominal width is 13 millimeters, and my nominal height is 75 millimeters, that's the bounding box. So my calculated X1 is 13.16 and X2 is 18.93. So you can see that the X1 width is not much bigger than the nominal. So the nominal was 13 and the new X1 dimension is 13.16. So it's almost negligible when we move the graphic only 3 millimeters down from the larger diameter. So now when we go to distort our group of graphics, earlier I had mentioned that the free transform perspective distort will not work for groups of graphics. It worked nicely for just a square, but you can see as I distort this graphic, the pineapples get shorter as they get wider. So we're going to use a different method when we have a group of graphics like this. So to avoid the perspective shortening of the graphics, I'm going to take the rectangle that we just drew, I'm going to copy it, I'm going to paste it, and I'm just going to change its color here so it's a little easier to see. On this empty rectangle, now I can use the same tool. So I'm using the Free Transform Perspective Distort, and I'm going to size it to our calculated dimensions. So in this case, I got pretty close to 18.93. I think it was 18.97 there. Again, don't stress out too much if it's not exactly the same. And the top edge of the rectangle I left at 13 millimeters, which is X1, because it's just so close to the calculated 13.16. Then I took my group of pineapples as well as the original rectangle, and I grouped them together. Then over on the right hand side in my layer list, I just need to make sure that the distorted red rectangle is one layer above that group, and then I can select both and align them together. And once they're aligned, we can go up into Object, then down to Envelope Distort, and Make with Top Object. And now you can see our group has been distorted to fit the red rectangle that was on top without the shortening that you would have gotten from the Free Transform Perspective Distort. Now I can use the Expand tool so I can select the objects in that group, and I'll just select the rectangle and delete it. And now all we're left with is our properly distorted pineapples. And after that, it's just a matter of following the exact same procedure that I've shown you several times now in this video of using the Grid tool to pattern and space our objects. And then once we have them centered on our artboard, we can draw that background rectangle, which is going to help us out later on in XTOOL Creative Space when it comes to framing. And just one final tip when patterning these groups of graphics, you'll need to leave a sufficient amount of negative space between those graphics to make sure they do not overlap one another when we go to do the full wrap engrave. You'll see what I mean when we process this job. Back in XTOOL Creative Space, this process also has not changed from previous examples. So I've imported the image and I've just rotated it 90 degrees. I'll be aligning the image to the center of our workspace. Then I'll be ungrouping this vector file so I can separate out the green rectangle in the background and then regrouping all of the pineapples back together. To make the framing process faster, I'll just temporarily switch off the output of the pineapples and hide them. And then I'll bring back the green rectangle and just, again, temporarily use this as my output. And this typically makes the framing process faster because XTOOL Creative Space doesn't have to consider all of those details of the pineapples. And as with previous examples, I want the left and right side of my projection to stretch across the entire tapered surface. If you recall, in our calculator, the Y1 dimension was 3 millimeters, and so the pineapples inside of this green rectangle are 3 millimeters from the top of the rectangle, essentially placing this pattern of pineapples 3 millimeters from the larger diameter of my taper. This is why I really like using this background rectangle trick to frame my graphic, because it's easy to account for spacing and positioning of the graphics without having to try and measure anything during the framing process. As you can see, I was running out of sample workpieces, so I had to reuse the workpiece with the rectangles on it. So again, just ignore those, but you can see that the pattern of pineapples came out looking great. From top to bottom, the pineapples came out looking very uniform, so they are no longer squished looking at the bottom. But what you will notice is that the negative space between those pineapples is smaller at the bottom. And this is why I mentioned earlier that you need to leave a sufficient amount of negative space between your objects. And this is also why you cannot use this distortion method to correct a continuous image. Had this image been continuous in the sense that it had connecting features all of the way around, it would still look squished at the bottom. You cannot escape the fact that there's less real estate to work with around the minor diameter of the cup than there is around the larger diameter. And so that's where we use the negative space to our advantage. So now let's use a real wine tumbler for our next example. We'll begin by taking the measurements of our workpiece. So we'll start with the minor diameter, since this workpiece here has the smaller diameter at the top and it's about 80 millimeters. Then we'll find the widest point, which is about 88 millimeters. And then we'll find the distance between that widest point and the top of the tumbler. And in this case, it works out to be about 75 millimeters. Then I can get it mounted in the tilt mechanism and make the necessary adjustments so that the surface that we'll be engraving is parallel with our laser. And for this example, we're going to be working with a round logo. And I'm going to show you guys how to use our bounding box solution around this round logo. I've changed the dimensions of this logo to be 45 millimeters by 45 millimeters, and then I'll go ahead and draw a square around it of the exact same size. So essentially this square will be 45 by 45 and its edges will just touch the edges of the circle so that the circular logo fits perfectly inside. Then I can just group the logo and the square path together before we move into our calculator. Just as with every other example, we'll be using our calculator the same way. So this time we have a major diameter of 88 millimeters, a minor diameter of 80. The height was 75, so it's the distance between those two diameters. In this case, I'm going to be placing the graphic 15 millimeters from the larger diameter, and our nominal X and Y is 45 by 45. And so now we have our calculated X1 and X2 dimensions. Back in Adobe Illustrator, I'll be making a copy of the bounding box square. So I'll just select that in the layer tree, use Ctrl+C and Ctrl+V to paste it on a layer above the logo and square that I had previously grouped together. Now I can use the freeform perspective distort on the empty square to get as close as I can to those calculated X1 and X2 dimensions. And in this case, take special note because the top of our tumbler is a smaller diameter than the bottom. And so you'll see that I'm flaring out the top of this rectangle to be the X2 dimension. And this is an extremely important concept to understand when using this method because the top of our logo is closest to the smaller end of the tumbler. So we need to flare the top of the logo outward to compensate for the taper. Once we have that second bounding box to the desired shape, we can go back into Object, Envelope Distort, and select Make with Top Object. When using that tool, it's imperative that the distorted rectangle was above the layer with the graphic and the not distorted rectangle. Then we can expand our selection, find the bounding box in our layer tree, and then just delete it. Then I'll go through the same process as with previous examples where I'll be creating that background rectangle, and I'm going to make sure my rectangle and artboard are the same height as the tapered surface of this tumbler, which was 75 millimeters. If you recall, in the calculator, I entered 15 millimeters as my dimension from the larger diameter to my logo, and that's because with the tapered surface height of 75 millimeters and the logo being 45 millimeters, when it's centered, that works out to 15 millimeters of dead space on the top and on the bottom. And then back in XTOOL Creative Space, we'll use the routine that you guys should be familiar with by now, where we're just going to place the entire graphic inside of the workspace, and we'll use our background rectangle to frame it on the tapered surface of our workpiece. And just a reminder, when you're rotating your logo, just always be mindful of which end of your workpiece is up and which end is down, so your logo doesn't get flipped upside down. And so here we'll be framing the logo from the top edge of the cup, and you can see that if I've got my distance right, which is about 75 millimeters, that projection line will go from the top edge to about where the widest point of the tumbler was that I measured at 88 millimeters. Then back in XTOOL Creative Space, you can see that I've hidden my framing rectangle, and I need to enter some settings for this tumbler. And if you guys happen to be working with the XTOOL F1, I made a video specifically about tumbler engraving with this machine, and I'll link to that in the top right hand corner of the screen. I would highly recommend you go check that out if you're looking for more details about engraving tumblers and water bottles with the XTOOL F1. I've got some tips and tricks in that video that I think you guys would find really interesting. One of these tricks is using the F1's dual laser system, so I like to use the blue laser first to remove the bulk of the coated surface, and then I hit it with the IR laser next, and that really brings out the bright metallic surface underneath. If you're using this method, it's just really important that you do not disturb the workpiece when switching between the blue laser and IR laser so that the alignment is perfect. The result is a really sharp looking graphic, and even though the paint on this tumbler is blue, the blue laser was still able to remove most of it, and the IR laser removed the rest, and as I had mentioned, it leaves you with this really nice, shiny, bright surface. When you clean it, it looks great. And if you look closely, I think our circular logo still looks like a circle on this tapered surface, and it doesn't look egg-shaped, so I would say that our graphic correction is working nicely even with round logos. I have one final trick for you guys when working with tapered surfaces so we do not get distorted graphics, and that's to not use the RA2 rotary module at all. I've got these V-block fixtures on my website, embracemaking.com, and they hold round objects in the XTOOL F1. If you don't have an XTOOL F1, you can still make something like this work with a different machine, but the idea here is with a tapered tumbler or object, you're going to just need to lift it off of that V-block a little bit so that the surface, again, is parallel with your laser. And the surface is obviously still round and not flat, and so as you move away from the center of your round object, the surface will fall away. Therefore, I like to focus my laser just below the center of this surface so that I can engrave a little further down the sides before the laser falls out of focus. And if you're working with XTOOL Creative Space like I am here, you can see that I've got it in the flat base plate mode, so it's not in rotary mode. And then I'll just take my logo and I'll place it somewhere in the center, and I'll position it downwards a little bit so that it lands right in the middle of my tapered surface. Then I can frame this square logo and make sure the size of it doesn't extend too far down the sides of the round surface. And so although this method is very easy, this is the limitation of this method. Because you're not using the RA2 rotary module, you cannot wrap the graphic around the surface very effectively. You have to limit yourself to a very narrow and thin logo. But if that works for your use case, you can see how quick and easy it is to avoid the rotary system altogether, and with no workarounds at all, you end up with a dimensionally correct and square logo. So you can see that even though we're working with a round surface, there is a little bit of leeway with the laser focus where everything still looks good as long as you're working within that tolerance band. So that's it for this video. I hope you guys found this topic interesting and helpful. And remember that all of the concepts in this video can be applied to any machine. I was only using the XTOOL F1 for demonstration purposes. And as always, remember that everything I referenced in this video will be available in links in the video description down below. So be sure to go check those out, as well as visiting my website, embracemaking.com, for more upgrades and accessories for your laser machine and for that very useful calculator that I used in the demonstrations in this video. And finally, don't forget to check the link in the video description down below for that very special offer from XTOOL on the brand new XTOOL F1 Ultra. I've got videos on that machine coming out very soon, so hit the subscribe button so you don't miss them. I cannot wait to show you guys what that machine is capable of. Thanks for watching.